Hello friends, today we will discuss how to draw shear force and bending moment diagram for a simply supported beam loaded with UDL and point load. For that we will consider one example. A beam of 6 meters span is loaded with UDL of 10 kN per meter for a length 3 meter from left support and a point load of 15 kN at a distance 5 meter from left support. Draw SFD and BMD. To start with, let us find the reaction. This is the diagram of a 6 meter span AB. UDL is 10 kN per meter for a length 3 meter from left support up to C, and a point load, concentrated load at a distance 5 meter from left support. So this is the diagram, and let us start drawing the shear force and bending moment diagram. At A there will be vertical reaction RA, and at B there is a vertical reaction RB. Now to calculate reactions, for reactions we will apply the basic conditions of equilibrium. Sigma Fx is equal to 0. This condition is already satisfied as there is no horizontal force. So this sum is 0. Then second condition, sigma Fy equal to 0. For that we will consider upward force positive, downward force negative. Ra upward, so I will consider it as positive, minus the UDL is given as 10 kilonewton per meter, and in this case it is spread for a length 3 meter, that is from A to C. So for 1 meter it is 10, so for 3 meter it is 10 into 3. This is minus, it is a downward load, minus 15, that is the load acting at D, plus RB is equal to 0. So RA minus 30 minus 15 plus RB is equal to 0. So RA plus RB is equal to 45 kilonewton. This is our equation, say 1. Now to calculate the share of RA and RB out of 45, let us apply the third condition of equilibrium, that is sigma m is equal to 0. For that, I will consider all clockwise movement positive and all anticlockwise movement negative. Now let us take moment about B. So we will consider distances of all the forces up to B, and clockwise movement positive, anticlockwise movement negative. To start with, RA into 6. This is a clockwise movement, so positive, minus. Now, how to calculate moment of this UDL up to B? For that, what I am going to do is consider this beam and the total UDL. Remember the total UDL, which is 10 into 3, that is 30 kilonewton, is assumed to be acting at the center of the UDL length. In this case, it is 3 divided by 2. Remember, for calculation purpose, for calculation of distance of UDL, it is assumed that the total UDL is acting at the center of the UDL length. So in this case 3 by 2, that is 1.5 from A and 1.5 from C. Now as we are taking moment about B, RA into 6 minus into bracket 10 into 3 is the total UDL and it is acting at a distance 3 by 2 plus 3. See, 3 by 2. We are taking moment about B. So 3 by 2 and this distance is 3. So total is 4.5 in this case. Then moment of this 15 kilonewton load. So minus 15 into 1, it's the distance of D from B is 1 meter plus RB into 0, no need to write, that must be equal to 0. Now let us calculate 6 RA now 30 into 4.5, 135 minus 135 minus 15 is equal to 0. So 6 RA is equal to 150. Therefore, RA equal to 150 divided by 6, that is equal to 25 kilonewton. Now let us take moment about A now. Moment about A, all clockwise positive, anti-clockwise negative. RA into 0, no need to write. Then moment of the UDL 10 into 3 into 1.5 or 3 by 2. This is clockwise movement. So plus, I will repeat, we are taking moment of the UDL about A. 10 into 3 is the total UDL which is acting at the center of UDL length, that is 3 by 2 from A, that is 1.5. 3 by 2 is 1.5 plus 15 into 5 minus RB into 6 is equal to 0. So let us calculate this again. 30 into 1.5, that is equal to 45 plus 75, here it is 120. So 6 RB is equal to 120 and therefore RB equal to 120 divided by 6, that is 20 kilonewton. Now let us check. RA we got 25, RB we got 20. So total is 45 which is tallying with the equation number 1. So whatever calculations done are correct. Now let us draw the shear force diagram directly. So I am drawing the baseline to draw the shear force diagram. This is the baseline. We got Ra equal to 25 kilonewton and Rb 20 kilonewton. So to start with A, 25 kilonewton upward. So this is 25. Then from A to C, there is a gradual drop of 10 kilonewton per meter. So for a 3-meter length, there is a gradual drop of 30 kilonewton. So 25 minus 30. So here I get minus 5. So below the baseline, consider my 5. That is minus, therefore it is below the baseline. I will repeat Ra 25, and then from A to C there is a gradual drop of 30 kilonewton. So 25 minus 30 minus 5. From now C to D there is no change, straight horizontal line. At D there is a drop of 15 kilonewton. And from D to B there is no change, so straight horizontal line. And at B there is a upward reaction of 20 kilonewton. So this is 20. Mark below the baseline and negative, above the baseline positive. Now let us shade this diagram like this. This is SFD and the unit is kilonewton. Now note down this point. This is known as point of contra shear. Point of contra shear. Contra means opposite. At this point, shear force becomes opposite, means from positive to negative, it changes the sign. What is the speciality of this point of contra shear? At point of contra shear, we always get maximum bending moment. I will repeat, at the point of contra shear, we get maximum bending moment. Now let us locate this point of contra shear by similar triangle method or applying similar triangle rule. I am drawing the portion of the shear force diagram between A to C. This is A, this is C, this is 25, this is 5. I am assuming this as X. The total distance between A to C is 3 meter. So this distance is 3 minus X. So using similar triangle principle, x upon 25, x upon 25 must be equal to 3 minus x upon 5. So x is equal to 25 divided by 5 into bracket 3 minus x. So x is equal to 5 into bracket 3 minus x. So simplifying further, 15 minus 5x is equal to x. So 6x is equal to 15. So x is equal to 15 divided by 6. It is 2.5 meter. So this point of contrast shear is at a distance 2.5 meter from A. And as I told you, the bending moment is maximum at this point. That is where shear force crosses the baseline. Now to calculate the bending moment at each point, let us consider first bending moment sign convention. For bending moment, we assume the sign convention like this. This is the section, the clockwise movement on left hand side of the section and the anti-clockwise movement on the right side of the section. We consider it as positive, and if this is a section, anti-clockwise movement on the left hand side and clockwise movement on the right hand side as negative. Now, bending moment at A, as it is a simple support and end support, it is always 0. Bending moment at B is also 0, simple end support. Bending moment at D, let us consider right hand side, because on the right hand side of D there is only one force, that is RB. So it is easier to calculate the bending moment at D considering right hand side. On the right hand side, 20 into distance is 1. This is anti-clockwise movement, but it is on the right hand side, so it is positive. So it is 20 kilonewton meter. Then consider bending moment at C. Again, right hand side. On the right hand side of C, there are two forces. Reaction at B, RB. RB into 3. This is anti-clockwise but on the right hand side. So according to our sign convention, it is plus, minus 10 into the distance up to C is 2 meter. So RB, we got 20 into 3 minus 20. So I'm sorry, the load here is not 10. RB, I will repeat, bending moment at C, RB into 3 minus 15. The load is not 10, it is 15 into 2, that is 30. So 20 into 3 is 60 minus 30, that is 30 kilonewton meter. I will repeat, bending moment at C considering right hand side, RB into 20, that is 60, and moment of this 15 kilonewton load, 15 into 2, that is 30. So 60 minus 30, 30 kilonewton meter positive. Now, maximum bending moment. For maximum bending moment, we know that it is at a distance 2.5 meter that we calculated using principle of similar triangle. The maximum bending moment is as 2.5 meter. Ra is 25 kilonewton and the UDL is 10 kilonewton per meter. Now, to calculate maximum bending moment, I will consider the left hand side of the section Ra into 2.5 Ra into 2.5 minus 10 into 2.5 into 2.5 by 2. So let us calculate this. Ra is 25 into 2.5 minus 5 into 2.5 square is equal to, now again I will calculate this, 25 into 2.5, this is 62.5 minus 2.5 into 2.5 into 5, 31.25, 31.25. So this is equal to 31.25 kilonewton meter. Okay. Now let us draw the bending moment diagram. For that, I will extend the lines or project the lines of the load. This is A, this is the point of maximum bending moment. This is C, D, and B. Now to start with, I will draw the baseline first. Then bending moment at A is 0, B is 0. Then maximum bending moment is 31.25. Here it is 30. Then bending moment at D is 20. Here it is 0. Here it is 0. So join these points by a curve because this is UDL there, and where there is only point load, join with straight line. So from C to D is straight line and D to B again is straight line. Mark it positive as it is above the baseline. Then shade it BMD kilonewton meter. Remember, from A to C, it is a curve parabola. Wherever there is UDL, below that we get a curve. So this completes our shear force and bending moment diagram.